We're going to hit the relationship between science and photography from two different perspectives today. I want to talk about using photography within your scientific pursuits, and also something that's near and dear to my heart, which is using a scientific perspective in your photographic pursuits. So the truth is that these two pursuits are extremely closely related, particularly in the art field of photography. The relationship between science and the product you create as an artist, they're almost indistinguishable. As you can see here on the left side of the screen, we have probably the most famous scientific photograph ever taken, photo 51, under the guidance of Rosalind Franklin in 1951, the photograph that gave Watson and Crick the final piece of evidence they needed to publish their paper on the double helical structure of DNA. So that's photography used to strengthen a scientific argument, used as evidence in a scientific study. Whereas on the right, we can see a photograph of a scientific phenomenon. Electrical fields discharged across photographic glass allows us to generate art using sort of the fractal structures of electrical fields, of lightning fields, and mimic lightning on a small scale. So my suggestion and my advice throughout the talk today is going to be to sort of use these two pursuits interchangeably. Consider how you practice and explore photographically as well as scientifically, and at any point in time that you can use photography to strengthen your science, or vice versa. The more you practice that, the more ingrained and simpler that procedure will feel, and the better results you might find. So as we consider photography's role, just as a little bit of background in science and scientific exploration, it's important for us to think about the aspects of the scientific method that are maybe have the most opportunity for the use of photography. So I sort of pulled out the ideas of observation, hypothesis testing, reporting our scientific outcomes, and long-term scientific monitoring as four really key places where you might engage in photographic pursuit while being a scientist. I think the most obvious one of these is observation. So, when it comes down to it, we are all trained observers. We start observing the day we're born. And we're really looking out here for something in the natural world that excites us and maybe incites a question for us to take the next step in our scientific exploration. Photography is an excellent tool for strengthening our observational skills. Whether we're looking at physical data, the boys in this picture are studying flow rates in Prosser Creek, right around the corner from here in Truckee, California, where we are making behavioral observations. One of the best uses of photography is this idea of seeing photographically, beginning to think about what your subject, how it interacts with the scene, and how you interact with it in order to get an effective photograph, which, when observing animals, can be really, really powerful. Your powers of observation get heightened and might lead you to ask questions about their behavior, or simply studying variation within organisms, trying to figure out which organism is different, how are they different, what variation is okay within the system that you're studying, or perhaps the timing and nature of their response to seasonal changes in the environment. So once you've made those observations, hopefully they lead you to ask a question. And when asking a question in science, we're often trying to come up with a hypothesis. So what is that potential explanation for the pattern that you're seeing? And our objective is to use the information we gathered from our observations, or maybe from knowledge that we've accrued through our experience, to make predictions. And using photography to design an experiment that tests that hypothesis. And when it comes to experimental design, this is probably the part that people struggle with the most, is making sure that their test actually is valid. It actually defines and defends the hypothesis that you are seeking to explore. So one of the most famous hypotheses that I teach in biology is sort of on the back end of our natural selection studies. And when we talk about Darwin's pursuit of the pollinator for the African star orchid, can't quite remember exactly which one it is, but an orchid with a 12-inch spur. Now, Darwin understood pollinator relationships with the plants, and he hypothesized that if this plant with a 12-inch spur existed, there must be a pollinator out there with a 12-inch proboscis. And later on down the line, we found that African hawk moth that has a 12-inch proboscis that was capable of pollinating that plant. So he's got a hypothesis, and we're able to sort of verify that hypothesis. In this case, the hypothesis that you generate, the things that you're looking at depend on what you're interested in, what sparks your sort of curiosity. Photography is extremely useful in reporting. This is a little bit less about science and more about engagement. The idea that by having a series of excellent photographs of your field study, of your experimental design, of your lab results, gives you an opportunity to engage the public. Scientific communication is something that we, as scientists, need to work on universally, whether we're excellent at it or we are still developing in that way. The way in which we communicate our ideas is critical in order to get engagement, get ears on our ideas, and that often requires us to have really compelling photographs to tell that story. And also long-term monitoring, whether it's tracking humpback whales with their sort of unique fingerprint-like tail prints in order to see their migration patterns and just verify that they keep coming back to their grounds year after year. Or just last week, one of our students caught a massive rainbow trout in the Little Truckee River, and I sent the picture to one of our local guides, Matt Heron, who immediately texted me back a picture of the exact same trout that a friend of ours had caught a week earlier. Just knowing gives us some information about how far these fish move up and down river, just because of the patterns of the spots on the fish are exactly the same. On a larger scale, Mono Lake is pictured here, and we can sort of get a sense of the depth of the lake. And for decades now, they've used photographs to communicate with the public about the advance and recession of the water line in Mono Lake in order to sort of communicate to the public, hey, depth of this lake is important. It's a unique ecosystem, and how we manage it has an awful lot to do with our patterns of water use. And photography is an excellent way to show us that, as well as communicate to the public the importance of the system and how it changes over time depending on human patterns of water use. So that's sort of like a framework for us to think within. And the original question was, what can I do? How can I incorporate photography into my studies? So I've got a few ideas here. We're going to start really simple with some of the things that your elementary school students and middle school students, you guys might already be doing in your classes, and sort of branch out, get a little broader, a little more self-directed as we go along. So one of the things that a lot of students are doing right now is looking for signs of spring in their backyards or in the parks around their house. And I think that seasonal change is a really fun thing to consider when taking photographs, whether it's simple exploration of the wildflowers that live in your neighborhood. There are other expressions of spring, obviously. Around here, we see various parasitic snow plants start to crop up. You may have access to standing water or rivers and lakes where you might see amphibians that are starting to lay eggs. All these sort of things are great signs of spring that can help connect your younger student with nature and sort of get them excited about what's going on outside during change, during periods of change. Obviously, if you are looking for an experimental approach to using photography in this way, these images can be used to predict times of change. When do we think these flowers will bloom? How does the community of flowers change from year to year? Looking at salamander eggs in this picture, we get to make predictions about when we think they're going to hatch and become larvae. And there's a lot of different long-term sort of things we can do. Change is always fascinating. Some of the most popular subjects to photograph around the nation are evidence of seasonal variation. Considering the timing of when leaves start to senesce in the fall is really compelling and fun photographic exercise that we can engage in. And both of these things, just getting outside, taking pictures, looking for evidence of change in our environment, could lead us to generate maybe a backyard catalog where we're collecting images of interesting biota in our neighborhood, in the area around our home, and just start compiling them and get a sense of what that community looks like, what that ecosystem might look like. And good pictures of these subjects, you'll notice there's nothing like too hard to track down here. Good pictures of these subjects can then be brought home, laid out in a layout like this, and used to identify or key out the species that exist in your system. Also going on, at least in our household right now, and I'm sure many sort of kindergarten and elementary school households around the US, a lot of our kids are growing their own seeds. This is a fairly standard curriculum. And we can use photography instead of drawing a flip book, drawing the sort of stages of change as our seeds grow for a flip book, as our younger kids start to understand how plants grow, how fast they grow, what kind of decisions they make, what they need to grow. They can take a series of photographs every day, make a little time-lapse video. Obviously, parents, you'd have to help out with that. Or we could print them out and sort of make a flip book out of those pictures. I guess a tip for this would be to just try to get your child to hold the camera in the same position every time. I can testify that that is a bit of a challenge and sort of adds a layer of difficulty for those supervising this activity. Slightly older students might be asking questions about growth rates. And it's pretty easy to put a ruler, like tape it onto the window right behind the plants as they're growing, make predictions about how tall they'll get, how much they grow every day, and sort of engage in a more predictive level with this kind of an activity. As we sort of increase in complexity, we're lucky to live in this day and age where there's so much connectivity and so much sourcing of information in the world around us. Citizen science is long emerged as a great way to harness the power of the public to make more observations than one individual or one lab could possibly do. There are a lot of different citizen scientist projects that engage photographically with the environment for monitoring, studying emergence, looking for invasive species, understanding water quality. There's a list of a number of them here. I'd highlight Citizen Science Lake Tahoe, the mobile app generated by Turk to focus on water quality and invasive species in the Lake Tahoe Basin. It's a really easy app to download for free, get registered, and start collecting data when you're at the beach. Other options on here that are really compelling for a young student include the iNaturalist app, through which you can generate your own BioBlitz or inspire your teacher to do so, in which you're sort of cataloging diversity throughout your local ecosystem. There are literally hundreds, maybe thousands of these opportunities out there to use your phone to gather data in a compelling way, learn more about your ecosystem, and contribute to real science that's going on nationally. This one is really flexible for all ages, depending on your level of engagement. Just making your own pinhole camera. This might not seem like a scientific pursuit on the surface, but the reality is that it is a constant process of experimentation to get proficient with a pinhole camera, and you don't need very much to do it. There are a lot of different directions out there on the internet. The link below is sort of the simplest, most ground level set of directions for getting started. Any light, tight box can act as a camera, so that part's really easy. You can use a box, you can use a Pringles can, you can use any sort of thing that you can close up as a tube or a rectangle. And all you do is get some photosensitive paper like Polaroid film, tape it into the back of the box, and punch a little hole in the front. It's usually a good idea to use some tin foil or wax paper for that hole. And then you can start experimenting right away and making experiments with exposure time, with the size of the pinhole, with your subjects, how much movement you're going to be able to pick up, all these kinds of things that turn this sort of throwback activity that I did in 7th grade in my art class into a really thorough and thoughtful scientific experiment. One of my favorite things to do as a photographer is to study animal behavior. I sort of alluded to this before. The opportunities that present themselves when you're in the woods with a camera to take photographs of animals in their natural habitat are really interesting. And they also can provide you with insight into how they behave, giving you the foundation to create hypotheses that you can use photography to explore. These two images, both of birds in the field, were both sort of provided me with an opportunity to think a little bit more deeply about the system that I was exploring at the time. If we scroll down to the next shot, we've got two marmots here that are engaging in some dominance behavior, trying to figure out who's going to be the king of the mountain. These are just entry points, right? What is the question that can come from this? As we get more and more comfortable with the system, we start making predictions that can broaden our ability to get effective photos and also to design effective scientific experiments. As I said before, long-term monitoring is a key focus of using photography in science. We've all seen the pictures of changes in glacial coverage throughout the US over the past 50 or 60 years. If you don't have a glacier in your backyard to take photos of, measuring change in any natural system is pretty simple using a camera. We just have to think about what it is, what subject it is that we might be taking pictures of. Around here, a lot of questions that Meg and Spencer get and that I get through the course of teaching students is, what's up with the lichen that grows on the trees? Is it, is the old idea that it grows on the south side of the trees true? How come it doesn't grow all the way to the bottom? And these are really easy places for us to sort of go out, take measurements, use photographs as evidence, and start to test some of those questions. Does it have to do with snowpack? Does it have to do with access to sunlight for these plants to grow? What does it have to do with? These are all sort of questions we can answer photographically paired with scientific thought. Sort of the top shelf of scientific exploration is to design your own inquiry. I'm going to be pretty broad on this one because it's highly self-directed. You're going to ask questions and pursue those questions according to your own curiosity. These pelicans I encountered in Santa Cruz a few years ago really forced me to ask a couple of questions about animal behavior. So as I see them flying around, as we often see with birds flying around, through the course of their migration, they seem to be highly in sync. They seem to be working together. And questions might arise about how deep does that go? How hard do we think they work to be behaving in a similar fashion? And as I spent time watching the pelicans, it became clear that their synergy together, their teamwork was exceptional. It was really high level. Now I think we all have this, sort of understanding as we see a flock of geese flying in a V formation over our head in the fall, coming back in the spring, that there's a high degree of coordination within a system. But as I started to observe these pelicans, it was clear that was just scratching the surface. We can see in this next picture that even their foraging behavior is extremely coordinated. As we see all of them sort of lifting their wings at the same time to dip their heads in, they're clearly working together as they gather food out of this pond, and is an ideal place, given the time and the curiosity, to ask a question and use photography to sort of record data about the degree of coordination that these birds are engaged in. So on the other side of things, how we can use science to strengthen our art, it largely comes down to being predictive. Now, photography, if you are a photographer, you've learned about principles of reciprocity, yet the technical aspects of how we execute a photograph that matches our vision. We have a sense that the way in which we interpret a scene and use light and engage with our shutter speed, our ISO, and our aperture provide us with the right amount of light to execute a photograph. And as we become more and more competent, more comfortable, stronger in mastering that craft, that stuff kind of moves into the background and gives us an opportunity to think about the natural world scientifically in order to generate art that we can do repeatedly by being predictive and engaging with the environment. So a few ideas, things that I like to do, things that you might find interesting that do require predictive nature and experimental nature. The first one, and maybe the most obvious one, my students certainly gravitate towards this right away, is to play with long exposure, to consider the amount of light in your scene, how long you can make your shutter in order to end up with the effect that you're looking for. This image took 5 minutes to expose and required an awful lot of experimentation in order to get right, given the large amount of light that was on the screen or in the scene at the time. Isabel, I'm in the middle of a presentation, honey. Thank you. Predicting the weather is something we know that is quite challenging. But if we are paying attention to patterns, we understand our local topography and system, we might have a better chance at getting the results we want. Around here in the sort of the Donner Lake Basin, just outside of Lake Tahoe, just north of Lake Tahoe, we often get these patterns of thermal inversion, which stack clouds over Donner Lake, stretching up the mountainside. And if we have a firm understanding of how dew point works, how temperature works, how seasonal change works, we can start to predict the mornings when we're most likely to get this effect. In the summer, throughout the Sierra, we're often, I hate to complain and say we're plagued by bluebird skies. Most people love it, and I think I generally do too. But as a photographer, you want to know when the clouds are rolling in. When do you have a good shot at having a dynamic sky? Understanding the weather allows us to predict those kind of days where the temperature is just right, the moisture is just right, that we might have a little bit of a summer squall blowing in, giving us the opportunity for a more dynamic image. Fundamentally, the way that we compose an image is scientific in nature. I know it is artistic as well, sort of the aesthetic choices that we make and the conclusions that we draw are often feel very artistic, but the way in which human beings interact with art, with an image, is neurological. So if we can understand how the elements of design can draw an individual's eyes towards our image and allow them to spend more time with it, that puts us in a really strong position as an artist to increase engagement with our work, whether it's the use of leading lines or compositional rules. We're able to sort of hold the viewer's attention for a longer period of time and start a conversation about that work. Fundamentally, photography is all about light. Light is obviously one of the major units in your physics class. So understanding how light interacts, how it diffuses through clouds, what nature it takes when it's at a low angle as it's going down and coming up, how it behaves in the middle of the day, how it interacts with objects, increases our capacity to take photos that use light effectively and therefore are a little bit stronger in their artistic sense. One of my favorite things to do as a photographer is to look for symmetry and look for natural patterns. Sometimes that symmetry takes place as a reflection. Sometimes it's engineered, like with these flowers. It's also really fun and rewarding to explore the natural patterns that we see in things like flower growth. A little bit more on the technical side, scientific thought, technical execution is creating a composite. There are a lot of different ways to do this. This photo was taken by Etienne back in 1892. So this style of showing motion has been around for a really long time. Nowadays, how we set up a composite of a human or an animal in motion, taking multiple exposures on our camera. If we're shooting digital, we're then taking that into Photoshop and blending all those images together to make our composite. What we care about as a scientist is visualization. How do we ask our model to behave in order to execute that? How far apart do our pictures have to be in order to get the spread between each individual that we're looking for? So that's a little bit more of a technical idea. Really hammered on this earlier, but understanding wild animal behavior gives us a much better chance of taking effective photographs of animals in their native habitat. Just knowing when they're active, how they're active, how they behave with humans, what kind of range that they're occupying. All those things give us a much higher chance of getting an effective photograph of the organism that we're thinking about taking a picture of. More abstract, a little bit more subconscious. It's the idea that we can create paintings or photos that look like paintings from nature, all of this within the camera. This is a process of experimentation, which is why I included in this talk as we talk about using scientific skills. You're never going to nail this right off the bat. The picture on the left is a tree stump, and you can see that it's quite blurry. That's not done in post, that's done in camera with just the simple action of zooming in and zooming out on the lens while the shutter's open. As you can imagine, it takes a lot of experimentation to get that effect just right. On the right, we can see a different effect, not done by zooming in the lens, but done by panning the camera up and down the bark of the tree while clicking the shutter. So slightly longer shutter speeds on these, but it takes a lot of experimentation to get the image that you like. You may have to play around for an awful long time, but that experimentation can be really rewarding if you're happy with the outcome. Okay, and lastly, maybe the easiest place to think about how our choices and understanding of natural patterns can allow us to create effective imagery is looking up, taking pictures of our astral bodies. So knowing when and where to look for the Milky Way is really common. Astrophotography has become very, very popular over the past 6 or 7 years. And this requires a high degree of prediction. We have to know what phase the moon is, looking for a new moon so that the stars are as bright as possible. We need to know what direction that Milky Way is with regard, not just to the compass point, but also to the foreground elements or the background elements you might want to include in the image. And we need to think really hard about our light triangle as we make decisions about how we want those stars to look. And of course, it doesn't just have to be stars. We can play around with all sorts of elements, from the moon to the way the sun might hide itself behind certain elements in your composition. These are all really interesting ways to use the scientific experimentation, scientific mindset to take effective photographs. So as I wrap up for today, I want to just suggest that whether you're a scientist or a photographer or trying to be both, it's important to be curious, to make predictions, and to practice while you're exploring. All those things as habits of mind are absolutely going to lead you to outcomes that you feel confident in.